The use of composite bearings in the many fields of engineering can offer designers and engineers significant advantages over conventional bearing materials. The ability to offer maintenance-free bearing solutions or reduced maintenance intervals can give both savings in cost and expensive downtime of equipment. The ability to be installed and work directly in conditions that would normally require sealing systems and lubrication for conventional metal bearings makes them a very desirable bearing solution. In sensitive areas of marine, hydropower, water supply or food processing, this environmentally friendly solution has many benefits and the potential of significant cost-saving opportunities. One of the significant growth areas for the use of composites is in the offshore industries. A move towards lightweighting of topside equipment has seen composites become commonplace. Bearing applications in this market sector have also significantly taken the place of conventional metal bearings. The big advantage is the maintenance-free, fit-and-forget capability of these composite bearing solutions. Maintenance doesn't happen most of the time. The environment can be very aggressive, so the ability to perform straight out of the box is very beneficial. Many benefits can be gained in rotating mass equipment. The low density of the material at 1.35 grams per cc and the high strength to weight ratio can offer considerable weight saving opportunities. Applications below the waterline need no sealing or lubrication provisions. The selection of the correct material for the bearing counterface will give long-term bearing performance. It's an excellent insulator and prevents the potential of bimetallic corrosion. We can paint a glowing picture for the use of composite bearings, but we must be realistic. Although they can offer many advantages, it can't do everything. There is a limitation to its capability. It's important to recognize what those limitations are. We need to ensure that all the details and the dynamics of the application are carefully considered. It's important to understand, by comparison to metal bearings, our materials have much higher levels of thermal expansion and much lower thermal conductivity, and a considerable difference in modulus values. Unlike metal bearings with a single Young's modulus, our composite materials are anisotropic and require different design criteria. It's most important to understand that metal bearing tolerances and fits don't work on our composite bearings, due to that significant difference in modulus values. With the correct design criteria applied, a certain amount of compensation for these characteristics can be accommodated, and a changeover to composite bearings can, in most cases, be achieved. The real Achilles heel is the elevated temperatures, and most bearing failures can be attributed to not recognizing the compensation for loss of performance attributed to this fact, or its inability to tolerate the thermal excursion that many metal bearings can work under. However, in the final reckoning, our Tufcot materials have found hundreds, if not thousands, of very successful applications around the world. But as a company, we are investing in R&D projects to develop the next family of high-performance Tufcot composite bearing materials for the next 37 years.